My mother is an excellent cook. As a kid growing up, my sisters and I would join her in the kitchen often, and we learned at her knee, for example, how to make her spectacular brisket. She would pat down the meat, she would put on her special spices and seasonings, she would cut the tip off it, make it nice and square, put it in her pan, and a few hours later, we would have a delicious meal. Fast forward to present day, and a couple years ago, my mother was in our kitchen and she was watching me make her brisket. And I patted down the meat and I seasoned it up and I chopped the end off it, at which point she said, "What are you doing?" And I said, "Well, Mom, I'm doing exactly what you taught me to do. You have to cut the end off the brisket to make it nice and square." And she said, "My dear, I cut off the end of my brisket because I have a small pan. You have a much larger pan. You don't need to cut off the end." The moral of that anecdote is that we develop habits and processes throughout life for various things out of need. But sometimes we find ourselves cooking in a different pan, and the rules can change. And that's where we are today in lighting. So we're going to explore our new pan of lighting today, and I'm hoping by the end of our session, you will have developed an understanding of the lighting industry and all of its players. You'll discover new steps that help us develop a coordinated construction package. You'll learn about the importance of an accurate lighting budget, how to work towards it and avoid value engineering, and finally, be exposed to some different models for procurement that we have had some success with where we were able to write a single name specification. And our agenda today is how we will do that. First, we will talk about the business of light. Then we will delve into the technology and specification portion of the presentation where we will compare legacy and LED products and how things have changed. And finally, we'll delve into some case studies and explore how you can indeed get what you want with a single name spec. So we'll start with the business of light. Here's a diagram showing the typical structure of the design side of any construction project. So you have the client who has a project in mind, they hire a design team, and that's made up, of course, of the architect, interior designer, and all the sub-consultants. And I'm just breaking out the lighting consultant for the purpose of our discussion. Now, the lighting designer's role throughout the different phases of design are shown here. At the very beginning, even as they are developing the architectural concept, we start talking about budget. And we need that number in order to help drive our decisions of, for example, good, better, best throughout the rest of the phases to make sure that we can stay on that budget. We have to know what that is. During the lighting concept phase, that's really very design centric. That's all about all kinds of details. From space to space, we go through various details and make very specific decisions to achieve our objectives. And that is everything from shadows and contrast evaluation, looking at the different materials and finishes, what kind of task are we looking at, etc., and codes. So there's tons and tons of detail in this phase, and of course, driven by the budget. We then get into the construction phase, and this is no longer centered around the design, but we're trying to develop a package so that our project is buildable. We are putting together the documents that show the technology that we're specifying, the layouts, the details, and this is when we coordinate with all of the other disciplines as well to ensure that we have a very tight construction package for the contractors. Finally, after the project has gone to bid and the construction project is awarded, the role of the lighting designer is really that of compliance with the construction documents, making sure specs are met and drawings and layouts are being constructed as designed, and of course the final tweaking, the aiming, and the setup of any last equipment. Now, as lighting consultant, we don't do that in a vacuum, of course. We coordinate with the other disciplines, but we also work very closely with lighting manufacturers and their agents. And we're going to explore that relationship a little bit now. So who is the manufacturer? The manufacturers are the ones, it seems obvious, of course, they're the ones that design and test and build the light fixtures. And these are the activities that they have to do. And we're going to focus a little bit on the bottom end, which is the technical support and bringing that fixture to market, keeping in mind that the goal of the lighting manufacturer is to sell their specific product or product lines. They have a very specific widget, very specific fixture, and that's what they have to sell. Now, in order to bring the product to market, they have to be able to provide technical support so that people like designers and contractors understand what it takes to work with that fixture. They also have to provide representation to specifiers, contractors, showrooms, et cetera, to let everyone know about their products. And to do that, they also need quotations and other support activities from inside salespeople. Now, a manufacturer may not be national. Say their office is in Montreal, their factory's in Montreal, but they want to be able to sell their product across Canada. So what they may do if they don't want to hire their own direct sales force is they will engage different manufacturers, agencies rather, throughout the country, and they will ask them to perform that function of technical support and bringing the fixture to market. Now, the agencies themselves want to have many lines to represent. So, for example, they can respond to requests for outdoor lights and indoor lights and hospital lights. So they want to have a number of different lines. So whereas the manufacturers may make a specific product line, the agencies may represent several different product lines. Now, for the purpose of our discussion today, the manufacturer and their agents are effectively play the same role to us as consultants, okay? With two points I want to make on that. So the first is that the relationship between manufacturers and their agents, they do change occasionally. Manufacturers may want a different agent, or the agents may pick up a similar line that they think they'll do better with, and they may drop a manufacturer, and that's all in their contracts. The second point I want to make is that once the fixture is built, the first layer of markups on light fixtures happens here. The manufacturer's agents, the agencies, need to get paid for the work that they do. So that is our first layer of markup. Now, I've very specifically shown the relationship between the agencies and manufacturers and the lighting consultant as a dotted line. Because be very clear, there is no money changing hands here. We do not get paid as independent consultants. We don't buy or sell product. This relationship is only to help the manufacturers get their products to the market. As lighting consultants, we're looking for the best luminaire to suit our design objectives, and the manufacturers are the experts in what they have that could possibly suit that need. So we work together, and often this relationship on a specific project can take quite a long time. We might be specifying something today on a big project, but it doesn't go out for tender for a few months, and then they don't actually buy the fixtures till months after that. So these manufacturers, agents and manufacturers are waiting some time to get paid for all the work they do for us to help us specify their product. Now let's move towards the construction phase. So we have put together our contract documents. We've got drawings and specs, and they're nice and tight. We've done all kinds of work to make sure they're coordinated, and we've specified exactly what we want. And now the owner wants to build their project. So here's the concept and the ideas. Here are the guys that are going to make it happen. So in order to have a construction team, the owner will hire ultimately a general contractor who will hire all their sub-trades, the electrical contractor being one of them. Now, the electrical contractor is not only responsible for buying luminaires and lighting, but they also have to provide all the electrical equipment, right? So they've got to buy wire and conduit and breaker panels and whatever, all kinds of electrical equipment that goes into a building. And they do that through an electrical distributor. So think of the manufacturers as the people that make the cornflakes. And the electrical distributor is the grocery store. So this is where the actual purchase takes place. Now let's explore the electrical distributor a little bit further and what is their role. Now, an electrical distributor represents numerous kinds of electrical products, as I mentioned, and they focus on the sale for that project, not individual manufacturers. They're quite happy to sell a luminaire from any of the manufacturers they represent. And typically what they will do when they get a request for pricing for a project is they will provide that price, but only in a lump sum in a package with the bill of materials. So there's no individual pricing on it at this time. Now, should the electrical distributor actually get the job and be the one to supply that project, they play a very important role as the project materials coordinator. And what that means is that it is their responsibility to make sure that shop drawings and approvals happen at the right time. They, of course, have to make arrangements for shipping and duty, often from all kinds of places all over the world. And they also are responsible for delivery scheduling. They have to be a reliable source for all the products that the contractor needs and for when they need them. So you don't need your light fixtures first and your wiring second. You need your conduit and wire first, and even with your light fixtures, you may have 10,000 fixtures on a project. Do you want them all drop shipped the same day to your site? Probably not. So the electrical distributor has an important role to play there with materials coordination. They also act as the bank, because basically what happens is the contractor has to order the equipment, but they don't pay for it until the equipment is arrived on site and the owner pays them. So the electrical distributor has to front some of that money to the manufacturers upon ordering. So they actually act as a bank, and there's often, credit arrangements with the different manufacturers. The final point I want to make is the electrical distributor is now the next layer of markups on product. So when the distributor buys it from the agent, they also mark up the product. And that is the basic structure on a successful project. Now let's talk about what actually happens during the tender period, during the bid period, before those contractors are selected. So the owner is actually going to go out to several general contractors. Let's say they're going out to 2. And each of those general contractors, let's say they're going to also get bids from various sub-trades, not just one contractor, probably 2. Now at tender time, if we've written our specifications the way we always have, where we put 3 names in a spec. So, fixture L1, is going to be this 2x4 fixture by manufacturer A, or it could be, this fixture by B and this fixture by C or equal. This is what happens at tender time. The electrical contractor is faced with many choices. First of all, they're going to decide who they have the best credit terms at this time with. So who do they actually have room to work with? And they'll also consider which distributors can provide the most equipment that they need. So they don't have to shop at many distributors. They can actually do it with one. But each distributor deals with different manufacturers. Some are overlap, some are not. And each agent, may have certain lines. So you get this kind of spaghetti arrangement of possibilities of what could be supplied on the job. And if we've allowed the or equal fairy to appear in our specifications, that makes it even worse, because then what the contractor can do and the distributor can do is they will select the distributor that has the most available product that is specified. And for what they don't have that's exactly specified, they'll pop in their or equal and they'll substitute it out. So they'll try to make something like this happen. Okay? And ultimately, the months of work that we as designers have done, and all of that coordination and all of those specific choices that we have made, we have now left it up to the contractor and the distributor to decide which products get selected. This is particularly a problem with LEDs. And we're going to explore the technology, the old and the new, to see why this is becoming even more problematic now with current technology. So we're going to start with color. Color used to be defined in part by color rendering index. The color fidelity was defined by taking 8 swatches, as you see here, and testing how closely that light source would accurately render the color. Now, it wasn't a perfect system, but it was easy, and we kind of knew how to work with it. So CRI is a term that you probably still hear today. Now, when we looked at fixture specifications such as this one, you'll notice perhaps that while they define the lamp type, they don't really talk anything about color or color rendering index or color temperature even. And that was because with legacy technology, all of that, the color came from the lamp. And like it or not, whatever we might feel about a cool white fluorescent lamp, a T8 lamp, with some experience, we knew what that meant. And when it came to color consistency across a project, all we had to say was all the lamps should be by one manufacturer. And we knew that the compact fluorescents would closely match the 2-foot and the 3-foot and the 4-foot fluorescent lamps, so that all fixtures, regardless who made the fixture, would have the same color properties, or very, very similar. And how many lamp manufacturers were there? Well, there were 3 majors. We could stretch it to 5. So, and we knew that even among them, there were maybe, one manufacturer was a little more on the greens and one was a little more on the pinks. But again, with experience, we knew how to predict the color on a project. Now, color, we know, is a lot more complicated than being able to evaluate on 8 color swatches. Here are just some of the terms that we came up with that help us define color. So now we have TM30 put out by the Illuminating Engineering Society, and they have tried to address some of the complexities of color. So for example, instead of 8 swatches of color, we now have 99, and they're not just colored, they're also textured, and we will evaluate the light source under all of those, and we will come up with a fidelity index, RF. So that's one metric. Another metric is the gamut index. So now we plot a reference light source and the light source that we're evaluating, and we look at the deltas and we come up with what's called a gamut index for the average level of saturation, and that's RG. And now we also have these vector graphics that we can look at. So whereas the one in the center, where the red is our test light source, it's perfectly sitting over the black reference. Whereas on this enhanced light source, for example, we can see that it will be more saturated in the reds and the greens. Whereas on this vector graphic, we can see it will be more desaturated in the reds and the greens. And now they've added Annex E to TM30, and what this allows us to do is to select color based on design intent. So the design intent may be for, a preference, a certain preference of a type of color that we may want to see. The design intent, the priority may actually be vividness. We may want to see, certain colors pop. Or the priority may be, for example, in a clothing store where you want to have accurate color rendition for color matching. And so depending on what our design intent is, we look for these metrics to be within a certain range. So that can help us with our color selection. The point I'm trying to make here is not to make everyone TM30 experts, but to make you recognize that it's not so simple anymore. And once we go down and evaluate and check all of these metrics, we usually come out to one answer, not or equal and or equal. So if we prefer the vividness, for example, we can say that we want those tomatoes to be uber saturated in red. Today, we also have warm, dim, and tunable white, and those allow us to determine what color is white on any given project. Now, back to the question of how many lamp suppliers are there now? Well, we don't have lamps, we have LED chips. And on many spec grade products, that chip is integrated into the luminaire. Now, we may be able to select color temperature and color accuracy among them. But between manufacturers, how easy is it to get color consistency across a project when there are, I don't know, hundreds, thousands of chip manufacturers? And even the chip manufacturers make different grades of LEDs. So color consistency today in our practice consists of obtaining many samples and often mock-ups to check and determine that we have color consistency. Now let's talk about technology in terms of the options for fixtures. So what we're looking at here are our go-tos for legacy technology. So I would argue that where we could write 3-name specs in the past were in things like troffers, where you had many manufacturers manufacturing the same style of fixture, would do very similar things, as well as with our downlights and potentially even wall washers, because in many cases, the performance really depended on the lamp as well. So for example, in this troffer with the center basket, there would be a lamp in here, and we knew what what fluorescent lamps would do. They would give you a diffuse distribution of light, and it was the reflector in the fixture that would guide the performance. So it didn't matter whose lamp was in there in terms of the performance for the most part. Similarly, with downlights, say you had an MR16 in this downlight. So it was the lamp that was doing all the work. Now here I would argue in the past, it was Not terribly difficult, if not easy in some cases, to write a 3-name specification. Where it got a little more expensive and a little bit more complicated was when we were trying to do modifications to fixtures and custom luminaire designs. We were limited by the form of the lamp envelope, and it could get fairly costly. Now today I would argue, and hopefully many of you will agree, that our troffer, instead of being a 2x4, is a linear. Now these linears don't just come in specific dimensions. You can make these linears anywhere. I've seen them from a 1/2 inch wide to 6 inches wide. They're not just 2, 4, and 8 foot long either. They can run in continuous long rows, as you see in the image on the right. These linears can have horizontal illuminated corners, and they can be mounted easily in walls. They can run, as I said, in custom lengths, but they can also cross at custom angles. They can be mounted in millwork and have inside corners illuminated in various lengths, custom lengths again. In this image, we're showing you that the mounting of this fixture, not only is it an L-shaped, it's 2 feet by 4 feet, but on this luminaire, we've got a surface mount, and on this end, it's actually a pendant mount from the structure above. So custom mounting options. And we can curve them in custom radii. So we have almost unlimited freedom in design. The only thing I don't think we're free to do is right or equal on something like this. Let's take a look at a halogen downlight at the spec sheet on a legacy technology. So halogen downlight, it was 1 page. We had some options. We could pick the finish, we could pick the voltage, and pretty well it. Now take a look at the same downlight for LED, and our 1 page has grown to 11 pages. Now we still get to choose things like the kind of lens and the flange finish, but there's also color selections to be made, beam spreads to be made, because we no longer have the lamp doing it, it's the fixture. And then we have a whole bunch of dimming options as well. And when you look more closely, the bulk of those pages is all about the different types of dimming that you can that can work with this fixture. Now, if we want warm dim, we're just down to 9 pages, not 11, but we still have a ton of detail to go through for a warm dim fixture. Now let's take a look at this, how this translate in practice with our first case study, very brief. This is residential corridors. So this is a condominium example and 30 stories. And in the elevator lobbies, we were doing some wall washing and having some downlights. And we narrowed it down to 4 spec grade options that we really liked and presented them to the client. Now, first thing to note is they are not equal. The light output varies from low to high. The difference is about 40%. The pricing, from low to high was up to 200%. So the high price was double the price of the lowest price. And frankly, aesthetically, if you are put on your interior designer or architect's hat, do the apertures look the same to you? And I would argue that they don't. Well, let's look at their performance. So we ran calculations of this elevator lobby. We were trying to wall wash the wood and then demarcate where the elevator doors were on the floor. Now, they may look similar, but when we actually look at the numbers and the calculations, and if you do look closely at these different renders, you should notice that they don't perform the same. And so we had a preference for two. And between them, there was a big price differential. And you may be surprised to note that the client actually went for the higher price option because they preferred the aesthetic of it. So, four good possibilities. I would say neither one is wrong, but one was deemed to be a better fit for this particular project. Another project, and we'll take this up in detail as we go through this, is the John Street Roundhouse, where we created, this is a roundhouse for engine repair for our train system. We had done this design to recreate the spokes of the wheel of the train. It's a whole park design, and those of you that were with us on our last presentation heard a lot about this. I'm just going to talk about the center part of it here, which is the turntable that we lit a few years later. And what we were trying to do is illuminate 120 feet of train engines on this turntable. And we were going to be doing it through linear floodlights on either side of the trains affixed to the handrails that ran along either side of the turntable. Now, we did a call to the manufacturers and their agents and told them what we were looking for, and we got 6 submissions of 6 different fixtures. 2 were eliminated because their driver wasn't a low enough rated driver to suit being installed by the lake in Toronto, where it can get quite cold. So we were left with 4 options, and here were the 3 that I'm going to talk about. And you can see that their distribution is not equal. Now, we preferred the one on the left and the one on the right. And even as pieces of equipment, they're not built the same. One of them, let's say this one, has what's called a remote driver. So every linear fixture, which is sitting here on the floor, is attached to one big driver somewhere else. This luminaire has an integral driver. So on each luminaire, there is a driver, making this fixture more expensive per linear foot by a factor of about, I think it was about 40% more expensive than this luminaire. The other thing I want to point out, that had we selected this one, we would have needed more luminaires closer together. So while, even if they were the same price, because you need more of them, the overall project cost is higher. So it really didn't suit the client's needs to be specifying, 3 different names when we knew that one was the most cost effective because of the layout that we can do, because of the remote driver. But it's a public project. So how do you write a single name spec on a public project? I want you to park that, and we'll get to that towards the end. Another case study is the Ontario Association of Architects, their headquarters building. And today I'm going to talk a little bit about the lounge and the main conference room and the meeting room. And the conference room and the lounge open up into one room. And this is very visible from the street as you drive by. And we were, this is what we started with. So this building was originally built in the 1990 or so. So it was 30 years later, and we are upgrading it. So this is not a criticism, but this is what we started with. Now, we were inspired by, a few years ago, this was something fairly new that had come out. I know there's several of them on the market now, but at the time it was new. And we really liked this fixture, and we went to the manufacturer and said, can you modify it to do something like this? And they came back with calculations that showed, yes, they actually could do it, and they could make it quite effective in terms of task light for what we needed it to do. And there was the rendering. Now, that just showed us how easy it was to have the manufacturers, bend and twist with LEDs, where clearly with fluorescent and old legacy technology, this would have been very, very difficult to do and very expensive. Now, the building went through a couple of iterations of design, so we didn't end up going with this. This is the direction we went, was with a square fixture, and this is that central conference room that opens up into that larger room. So these are direct, indirect with a really, really sleek form. But we also needed a modification for this round stairwell, and you probably didn't notice, but here is that same square fixture, but here it's bent on a custom curve to fit in nicely with the ceiling it's got. We also had a similar one built, but it's a surface mount for under this landing here. And you can see it in this image here. So these luminaires are the same luminaire family. Just want to point out also this color temperature shift, or what it looks like a color temperature shift, is in fact different glazing. The color consistency is really quite good on the inside. Now, that first iteration fixture wasn't all for naught, because we did come across this other project where this luminaire was a perfect fit for what we were trying to do with this sales desk in this retail application. For the manufacturer as well, they actually developed the fixture, and it's now in their permanent collection in their catalog. So again, how do you write or equal for something like this to make sure it gives you the aesthetic and the performance that you're looking for? Now, lamp life with legacy technology was pretty easy. We would take a sample of lamps, and when half of them burned out, we would say that is 100% of your rated life, and we would go further to say that at 80% of useful life is when you should do a group relamp of your legacy lamps. With lighting controls, that was often cut at the end of projects when everyone was out of money and the lighting controls were expensive. And they were particularly expensive because to dim a fluorescent lamp, we had to be using a special ballast. And the cost of the ballast, the dimmable ballast, were often prohibitive. So controls was something that was really difficult to do. Now with LEDs, lamp life is defined differently because, as you can see in the red curve here, LEDs don't just drop out and die like this fluorescent would, or metal halide or halogen, but they just simply fade over time. So we define them, for example, as an L70, or we will hit 70% of our lumen output at 50,000 hours. That same LED could be said to have a life of an L80 of 36,000 hours. Okay, so it's all by definition. Now, what about an L50 of 100,000 hours? Is that legitimate? Because the LED is still burning at that point. It's just the lumens have depreciated, but it is producing light. And how can we make use of that? Well, I think we can make use of an LED as long as it can provide adequate light for the application. And what we often do and what we propose, and this might be an extreme case to start at 20%, but if what we do is, as the lumens depreciate of the LED, well, we start at a dimmed level, and over time, we increase the dimmer to compensate for the loss of lumens in the LED. Now, lighting controls for LEDs are a little bit more, they're complicated to do. There's a lot of coordination that I'll show you in a minute, but a lot of the devices today are wireless. But here's, for example, coordination just with LED bulbs. Now, this is a couple of years old, but this is one of the controls manufacturers that would publish an 80-page document with regular updates to coordinate what bulb and what dimmer can be used together. It's not one size fits all now. LEDs and controls have also added another step to our specifications, another column where we indicate, is that driver integral or remote? And we also give some details. And this was the first example I picked when I first set up this slide. And it was so easy to find that here we've got one fixture with two inputs, one being DMX. One is an ELV and the other is another DMX. Some are 0 to 10. So there's a lot more detail involved in order to properly specify your fixtures to coordinate properly with your lighting controls. And when we say wireless, by the way, this is a residential we did, there is still wiring. It's the devices, it's the switches, the dimmers that are often wireless and the sensors that are wireless. But don't kid yourself, there's plenty of wiring back of house. Now, drivers and controls are not the only technology that are impacting us. And here's a quote from the Harvard Business Review almost 10 years ago. Twice before, over the past 50 years, information technology has radically reshaped competition and strategy. We now stand on the brink of a third transformation. And of course, we're talking about IoT, or the Internet of Things, those little sensors and devices that sit in all kinds of equipment that can help track all kinds of data from our cell phones and just know where we are and what we're doing. It's estimated that there are over 20 billion devices containing IoT in them today. And lighting is a particularly good target because of the pattern of lighting and that it exists every so many feet. If we can put those sensors in lighting, we have a fairly nice pattern of coverage that can really collect quite a good amount of data. And we can see this, for example, in this application. If you want, you can look up this, I think it's a video or report talking about this application, where here we have a warehouse where when they were using occupancy sensors, they could tell if a space was occupied or unoccupied, but that was it. If we use the fine detail that you can get, the data detail that we can get out of IoT and light fixtures, not only in this case could they tell that a space was occupied, but they could also tell where there would be a bottleneck. And that helps with productivity improvements. Another example of IoT in lighting, and this image is courtesy of Hammerschlag and Joffe, who designed Yorkdale Shopping Center. This is the winner of an IES Award of Merit. It's only in lighting do we get excited about parking garage lighting, but they've done quite a beautiful job. And why this is important is that it's Yorkdale Shopping Center is, I think, the 4th largest shopping center in Canada, but has the largest sales per square foot in Canada. It's about 250 retailers, some very high end. The problem with Yorkdale is the parking. They've got lots of it, but it was an absolute zoo because of all the traffic visiting. So they built IoT into the lighting. And so, for example, you can go online and check where you should park, where is there parking spaces. So IoT, while some of us feel that it's a little bit like Big Brother is watching, and he is, but we like these kinds of services. We like to be able to make those productivity improvements. So IoT is here to stay. And that's a good thing. But once again, how do you go through the detail of picking your luminaires, getting the right drivers, coordinating with controls, adding IoT to it, and then saying, oh yeah, or equal, you figure it out. So we've now come to the point where we're going to wrap it up with the procurement models and how do we actually get what we want. So we've talked about who does what in the lighting industry. We've talked about how we rigorously review products, all the data, the aesthetics, the performance. We mock it up, we get samples. And we've removed or equal from our specifications. How does this actually work in practice, and how do we actually get what we want? So we'll start with our case study of our residential corridors. So in this case, I had mentioned that the owner did indeed have a preference. This is an easy example and something that you've probably heard of before. And in this case, being a private condominium, the client had elected that moving ahead, they would be the ones to purchase the fixtures. Now that's great because they can negotiate their pricing, but it does run the risk that if something goes wrong during the installation, say the lights don't work, you get that finger pointing exercise where the contractor said, I installed it well, but there's something wrong with the fixtures that you bought. And the owner says, well, we bought good fixtures. There's something wrong with the installation. And it also puts the client in a position to be a procurer of product. They may not be used to that. So this may not work for all cases. It's not, it is a bit of an exercise to get procurement right with any kind of volume. But that is an option. So owner procured. Now, in the case of the John Street Roundhouse on that turntable, where I'd mentioned there were two fixtures that were close, but we knew that one was going to be less expensive than the other. And to complicate matters, not only did it have the remote driver, but it was a different dimming technology required depending on which fixture we were going to go with. So in order for us to write at least a two-name spec, we would have had to have two completely different designs. So the way we handled this, because the client really wanted to have two names on the spec, is we wrote the base spec for the product that we knew was going to work best for us and that was significantly lower priced. And we put the control scheme together. And what it said in the specifications is that the only alternate that we would accept would be product B. But if they elected to provide product B, the contractor was going to have to submit for approval and pay our fees for us to check it and to verify it and to allow it to be used. So that was the way we handled it. And in the end, of course, what happened? Everybody, all the bidding contractors proposed the lower cost option. None of them wanted to go through that work of developing the dimming details, and it was more expensive anyways, so none of them wanted to carry it. So it was technically a two-name spec, but effectively we knew what we were going to get in the end, on time and on budget. So writing a spec with selective options is the second approach that we've used. Now, this one is a little bit more involved, and it's actually worked well for us on a couple projects that I'll tell you about. So this is a retail shopping center, the Young Shepherd Center, and one of the major challenges, this was the existing, what we started with. So you'll notice that in terms of a retail mall, ceilings are fairly low, and they wanted to bring it up to an upscale mall. So it was really at a disadvantage compared to some of the competing malls that people may elect to shop at. This was the vision of the architects and interior designers. And you can see how light they made the ceiling. And part of the design intent was to raise the ceiling with light wherever we could. So you could see we do have a cove where we're trying to, to uplight the ceiling and visually raise it with light. And also these linears. And what we found were linears that had this lovely concave lens and gave a really nice effect, almost like you could put your hand right through the aperture. So we really liked it. We also found through the data and calculations that this luminaire had really terrific performance and an excellent beam spread, very wide, and we could mount these fixtures 20 feet on center and still get even illumination of those corridors with the proper contrast ratios against the brighter store windows, which is what we want. Now, we did look at other options. Really nice fixtures, nothing wrong with these. It just didn't meet all of the design criteria. We looked at all of them with samples and mock-ups, and we came up with a single name specification, and it did fit the budget. Similarly, we were using some multi-head fixtures, and the one that we elected to go with, again, a single name spec, because of this articulation, most multi-heads articulate up to 60 degrees. This one could articulate 120 degrees, allowing us to space these fixtures further apart. So once again, it's not the cost per fixture. Maybe another fixture would be 10% lower in price, a similar fixture, but we'd have to put them closer together. So the overall cost would actually be higher, including the labor, etc. So we came up with a number of fixtures, and on a lot of them, we had this situation on this project, okay? So what do? We're getting close to the bidding time, and the client had a couple of contractors price the project, and they came back with lighting that was twice what the budget was. Now, we go through that budget pricing exercise through the design phase. We don't just do it at concept where we say this is the budget we should be at, but every time we talk to a manufacturer or an agent, we ask for the budget pricing so we know what we're dealing with and whether we can afford it on the project, and we could. So there was no way that these numbers were right. And it took a bit of convincing to move forward in the direction I'm going to show you. So the first thing we did, of course, is, now this isn't exactly what we had because these guys weren't hired yet, but effectively we had a contractor going through a distributor and telling us that the price was double. So as a lighting consultant, of course, we go back to our manufacturers and agents who guaranteed us that the prices that they were giving out to the distributors were exactly what they should be to give us that budget price that we were expecting. So here's what we ended up doing. We developed a more formal pricing request to all the manufacturers and agents, and we asked for a guaranteed price from any major electrical distributor, so not from Joe Schmo who sells lights out of his garage, but the majors that are out there. And from that pricing agreement, we would determine a cash allowance for the contractors to carry. Now, this involved some extra work for us. This was outside of our scope, and it did cost our client about 0.5% of the savings that this exercise generated. So it was a very worthwhile undertaking. And we got to hold our specs. We got to hold our one name spec because okay, so hang on. Now, the manufacturer's agents got these pricing agreements and responded with the pricing that they had given us as budget pricing. And why did they do this? Because they knew that if they were to give us the right price that they had promised us, that they would actually get a sale, that they wouldn't be caught in a tender period where there were 3 other names against them and where the contractor got to pick who they were going to work with. It's also a more efficient process for the agents because they don't have to go through that tendering process and the back and forth and etc. So they knew it was guaranteed. Now for the contractor, in their tender, they were told the cash allowance for materials only. Now what that allows them to do is that during the tender, all that spaghetti of lines between the contractor, the distributor, and the agents, it all goes away. They don't have to go ahead and price every single fixture. They're given a cash allowance and they will draw against that to buy the fixtures. We also let them know that they were going to be given the pricing agreement so that ultimately they would know what the price per fixture was and what they were buying, but they wouldn't be able to mark it up later, only now while it was a competitive tender process. And for the electrical distributors, well, they agreed to sell the products according to the pricing agreements because, again, they didn't have to go through that spaghetti of trying to figure out which manufacturers they carried and who would they have to cross and, would they be getting the job? No, it was much more efficient for them. It made their job pretty easy. And ultimately, we were 3% under budget on the pricing agreements, and we didn't have to go through value engineering when the time came after tender, when they needed to find a few points to save, because we were already where we needed to be. And this is one of the images, just showing you some of the complications. First of all, yes, we indeed are 20 feet on center, and you can sort of see that here. We had some special applications like these special drop ceilings that we were lighting. There's a fixture on top here and it's reflecting off the ceiling above and lighting indirectly. We also had some round coves, several of them. And again, that's not a product you can specify with an or equal. Here again, we have, this is the entrance to the office buildings that are attached to the retail center. And you can see lighting in the millwork. How do you say or equal to that? Not a lot of fixtures can do that. So in the end, we had great success with Young Shepherd Center with this model. And we did the same thing, exactly the same thing for the Ontario Association of Architects, but this time we did it not only for the luminaires or the light fixtures, we also did the lighting controls by cash allowance as well. And finally, the last model, which is taking this even one step further. Now, this is a project we've just got on design, and it was supposed to start construction in April. Of course, it's now on hold as we're all on lockdown. But on this project, this was a condominium exterior lighting, and we're engaged by the structural engineers. And on this project, what we did is by recommendation of the structural engineers is we actually went out to a specific distributor that had a good relationship with the manufacturer of the products that we were selling. And we got the lighting quote. And we actually said in the tender form to the electrical contractor that here's your cash allowance. You're going to spend, say, $100,000 on these light fixtures. And you're also going to buy them from ABC Electric, and here's the contact name. And I thought that was might be a bit extreme, because then you're telling the electrical contractor who to bank with effectively, right? Who their distributor is. But we haven't run into trouble on this. We've done this on a couple of projects. So that's another way that you can really make that process very, very tight. So in summary, there are different ways that you can, in fact, get what you want with a single name spec, either owner purchase, through selective options that you're specifying but never saying or equal, or through cash allowances with those agency pricing agreements, or a pre-tender distributor price that you pass on to the contractor. It does involve a little bit of work, but that's the way that you can get exactly what you want. Thank you for your attention today, and I will now take your questions.